Blood flow through the gut varies according to what the gut is doing, right? If you haven't had a meal in 8 hours, well, you don't need a lot of blood flowing through your gut because you don't have a lot of digestion and absorption still happening. So we know that GI blood flow changes. We know that it increases when the gut is actively digesting and absorbing, but we don't know all the details about how that works. We know hormones play a big role, right? Several of the peptide hormones are essentially GI vasodilators. So they reduce resistance and increase flow. So like cholecystokinin, VIP, gastrin, and secretin all have this effect to increase GI blood flow. Two kinins from the GI glands, so calladin and bradykinin, are produced by some GI glands. They are also powerful vasodilators. So we have a number of effectors here. So we know the players, but we don't know the system diagram, so to speak, of what makes this and what makes this. So we have to keep it a little more vague. Now we know that a busy gut consumes more oxygen than a resting gut does, not surprisingly, right? The work of absorption and digestion isn't passive, it's ATP requiring. So also we get the oxygen demand theory happening, where a decrease in PO2 from a busy gut, to a busy area of the gut, that's going to be a vasodilator all by itself, right? Because we know that, such like any other capillary bed in the systemic system. So when we have a low PO2, we're going to have vasodilation, okay? And when O2 is low, we also get an increase of adenosine as in the A in ATP, right? So if you have a really busy tissue, ATP becomes ADP, then AMP, then A, right? So a busy tissue has high adenosine levels. High adenosine is also a vasodilator. So it's a good idea, because if you got a lot of adenosine, you need more oxygen because you're blowing through ATP really fast.